Oh, hi there, everyone. Thanks for showing up for your math learning. I was asked in the community about the Venn diagram method of finding the highest common factor and lowest common multiple. This is a really great trick to keep your thinking about HCF and LCM clear and to just deepen your understanding of numbers. You don't have to do it this way, but many of our students do. So I'll give you a rundown of this. The student asked about finding the highest common factor, lowest common multiple of 56 and 86. First step is to draw the Venn diagrams as I have here. And then we're going to find out what to fill the Venn diagram for 56 with. We do a factor tree and we find that 56 is divisible by 2. I'm just going to go ahead and eliminate primes. Okay, and that gives me 28. And then I divide that by 2 because it's still divisible by 2. That gives me 14. And then I divide that by 2. I get 2 and then I get 7. Okay, so that is to say 56 can be written as 2 cubed multiplied by a single 7. Okay, there's 1, 2, 3 factors of 2 and 1 7. Let's do the same thing for 86. Well, it's actually a simpler number. It's still composite. It's divisible by 2. But then I get 43 and I'm done because both of those are prime. The next step is to recognize that this 2 is kind of shared between the two numbers. They share that. So put that in the middle of the Venn diagram. And then we're going to fill in the rest of the diagram with whatever else we're needing. So we need a 43 over there so that this whole, all the factors inside that circle multiply to 86. And then over here, we're going to need another 2 factors, 2 or 4, okay, multiplied by 7. And that makes this whole circle multiply to 56. Now, the really cool thing is that we're going to find that this number in the overlap is the highest common factor of the two numbers. But what if we wanted to know the lowest common multiple? Well, the lowest common multiple, you multiply all of the numbers. Notice that we're not multiplying 56 by 86. We're multiplying by all the factors that build up both numbers. In other words, we're not multiplying by that highest common factor twice. Okay, so when we do that, we get 2 to the 3, because there's 3 2's there, multiplied by 7, multiplied by 43. One shortcut here would be recognize that that is in fact 56 multiplied by 43. 56 times 43 we can do pretty quickly in columns or in, I like to do a grid. So that's 43 and 56. 4 times 5 is 200. Yes. And then 4 times 6 is, this is 2,000. And then 4 times 6 is 240. 5 times 3 is 150. And 3 times 6 is 18. So we add all that up. And we will find that 2, 4, oh my goodness. My basic arithmetic is not very sharp right now. You can tell I don't pre-prepare my calculations so that I can amaze you. It's going to end in an 8, and that makes exactly, so 2408. 2408 is the highest common factor of 56 and 86. So that's how we would use that. Let's do another example, something like a few numbers that share a few more factors. I will rely on a calculator for some of this, but let's go. All right, first step, we've already drawn our Venn diagrams. So now let's go ahead and factor tree 750. I might note that it's divisible by 2, and that gives me 375. It's no longer divisible by 2, but I can spot that it's divisible by 3. So when I divide 3 into that, I get 125. Is that right? Yeah, indeed it is. And then I'd notice that that is no longer divisible by 3, but it is divisible by 5. So it's 5, and that gives me 25, and then that's 5 and 5. So that is to say 750 could be written as 2 times 3 times 5 cubed, 3 copies of 5. So I just go ahead and dissolve out the different primes, and once I'm done, I move on. So then 11, 5, 5. Okay, 100 and 1,155. I also notice it's divisible by 3. So when I divide that by 3, I get 3, and that's a remainder 2. So we're in there for 385. Okay, when I divide that by 3, I notice this number is not divisible by 3, but it is divisible by 5. So let's take out a 5. 5 goes in there 77 times. And then I notice 77 is not divisible by 5, but it is divisible by 7, and it gives me that. Okay, so I just go through and I look for the bigger primes as I go. So this one can be written as 3 times 5 times 7 times 11. So then I look for my overlap. Okay, here's my overlap. They both contain a 3 times a 5, but that's it. So I can write that in the middle, 3 times 5. I could even write 15. All right? And then that's our highest common factor, is 15. And then I fill in the rest. 2 times 5 squared, because I've got 5 squared there, and 2 that I still need to include. And over here I got 7 times 11. All right. Now, so the highest common factor in this case is the overlap. It's 15. And then this here, 2 times 5 squared, happens to be 50. And then this here happens to be 77. So to find out the lowest common factor, which is the bigger number, it's interesting, we would do 50 times 1155, because this number here is 1155. It's a little easier than doing 77 times 750, I think. So let's do 50 times 1155. That would be, gosh, I just want to do it like this. 50, 1155. So we're going to have a 0 there. That's a 5. Carry it 2. That's a 7. Carry it 2. That's a 7. And then 5 times 1 is 5. 57750. This is the lowest common multiple of these two monstrous numbers. 57,750. Okay. Now, you're probably wondering, I can do that already and I don't need your method. Well, I think you'll find, and I'm going to do a very simple example here with the numbers 16, 24, and 36, that it becomes very useful when you're trying to find the greatest common factor of 3 or more numbers. Because then you draw your Venn diagrams like this with your various overlapping sections. You do your factor trees. Okay. All right, and then 36, we'll just do it here. 2 times 18, which is 2, times 9, which is 3, times 3. Okay? So now I look for my biggest overlap, and it happens to be 2 times 2, so that goes in there, 2 squared. All right, I got to find other spaces for these numbers. Oh, and I see it shares one of them over there with 24. So let's put a 3 there and a 3 there. That's 36 done. Okay? Now, 24, I check and see what I've got already. I've already got 4 times 3. I've already got those, but I need this. And I see that it shares that with 16. So I put that there. 16, we've already got those and that, so we need a 2 out there. Okay? So that tells us that the highest common factor is 2 squared. 4 amongst all those numbers. And you probably already knew that. What's the lowest common multiple? Well, it'll be all this multiplied by itself. So 2 times 2 times 2 to the 2 times 3 times 3, which happens to be 144. So this is how we do with these types of problems. Okay? So, and how do I do lowest common multiple here? 2 times 2 is 4, times 2 to the 2 is 16, times 3 is 48, times 3 is 144. Okay, so that's how this method worked. Put in the comments below if you have a better way of doing it, or a way that you prefer, or, give me a point, thumbs me up if you like this method. Bye for now, everybody.